Hello and good morning to everyone. Today we're going to learn about electricity, the first lesson of physics. So today's topic is electricity, and we're going to have problem solving at the end of the lesson. So we're going to have 2 or 3 theoretical class, and then that will be followed by a problem solving class. So today let's start with the concept, the basic concept of electricity. So electricity, first of all, let's define what electricity is to get a clear idea about what electricity is. The phenomenon associated with charge either in motion or stationary is called electricity. So here we come across the term charge. So charge can be either positive or negative, and the SI unit of charge is coulomb, which is represented by C, and charge of electron, which is negatively charged, is minus 1.6 into 10 to the power minus 19 coulomb. So an atom is made of 3 particles: neutron, proton, and electrons. So the electron, which lies in the outermost shell of an atom, is responsible for the flow of current in a conductor. So electron is a negatively charged particle, and the value of the charge in terms of coulomb is given to be minus 1.6 into 10 to the power minus 19. Now what actually constitute the flow of current, or what is responsible for the flow of current? So we have learned that charge is responsible, or electron is responsible. Is it all the charge that is responsible? No. It is the free electrons which lies in the outermost shell which is responsible for the flow of current. So technically it should be free electrons that constitute the flow of current. It's not just any electrons, it should be free electrons. Then the direction of current, conventionally the direction of current is assumed to be positive to negative terminal, and the direction of charge or electron is negative to positive. There's a thing about this. Before scientists discovered or found out that it was electron or charge that constitute the flow of current, they assumed that the flow of current is from positive terminal to the negative terminal. But the actual flow of charge, which actually is responsible for the flow of current, is from the negative terminal to the positive terminal. Now why is that from negative terminal to the positive terminal? It's a very simple fact. A charge, or the electron which is responsible for the flow of the current, is a negatively charged particle, so it should be present in the negative terminal. So if it has to flow, it has to flow from the negative terminal to the positive terminal. So if you look at the side, the diagram is on. The blue dot which is flowing left to right, that's the electron, whereas the arrow, the red arrow mark, shows the direction of the flow of current. So conventionally the flow of the current is positive terminal to negative terminal, but the actual flow of electron or charge is negative terminal to positive terminal. Now let's try to define what current is. So current is the rate of flow of charge through a conductor. So how much charge can flow through a conductor in a unit time? That's how we defined current. And the SI unit of current is ampere. So current equal to charge by time. So how much charge can flow in in a unit time, that gives us current. So current is represented by I, and charge is again represented by Q, and time T. So let's define 1 ampere. 1 ampere equal to 1 coulomb by 1 second. If 1 coulomb of charge flow in 1 second through a conductor, we say the current is 1 ampere. So if 1 coulomb of charge flows in 1 second, the current flowing through a conductor is 1 ampere. Let's go to the next slide. Potential difference V. Let's define what potential difference is. The amount of work done to move a unit charge from one terminal to another terminal is known as potential difference. So talking about potential difference, you can take an example of a flow of water in a pipe. So if the pipe is kept on a plane surface where there is no difference in height, the water will not flow through the pipe unless there is a pressure from one end of the pipe. So in order to create the pressure, what you do is you take one end of the pipe to a higher level and then let the water flow. So in the same way, potential difference, the terminals, there should be potential difference between the two terminals, that is the positive terminal and the negative terminal, and only then current flows or the charge start moving. So there should be a potential difference between the negative terminal and the positive terminal in order for the current to start moving. So the SI unit of potential difference is V equal to W by Q. So Q is again IT. So because we have already defined the current, I equal to Q by T. So a simple simplification. So Q equal to IT. So 1 V equal to 1 joule of work done by 1 coulomb of charge. So we say the potential difference is 1 volt if 1 joule of work is done to move 1 coulomb of charge from one point to the other. So at this point we're talking about terminal. You can very well say from one terminal to the other, or you can also say from the negative terminal to the positive terminal. Now, how is this potential difference, which we have just discussed about, realized in a circuit? How is it created? So let's see. Potential difference is generated by a battery, one cell or more. So the potential difference, let's take an example of a dry shell. The positive terminal, you have the positive terminal and then you have the negative terminal. So the potential difference is created only if we have a power supply or a battery. Now the potential difference sets the charges or electrons in motion. In order to maintain the current in a given circuit, the cell or the battery has to spend or expand the stored chemical energy so that the charge can be in motion. So a dry shell, after it is being used for a period, the charges which are to move from the negative terminal to the positive terminal gets over and it stops flowing and it stops supplying the current. So there should be a potential difference, or the negatively charged particles should be more present in the negative terminal. So the potential difference, in order for the potential difference to let the current flow, some kind of chemical energy which is stored in the cell should take action and sets the charges in motion. So that's the how potential difference is realized in a circuit. So cell expands its stored chemical energy. So next we have resistance. What is resistance? In a very simple term, resistance means oppose or go against. So here we're talking about resistance of a conductor. So the property of a material component due to which it opposes the flow of electric current through it is called resistance of the conductor. So the SI unit is ohm. Now, talking about resistance, every conductor conducts electric current, but some conductor conducts better than the other. So there is something in a property that the conductor has which allows the electric current to flow more easily. So that also shows that there is a certain kind of force or certain property that the conductor has opposing the flow of the current or trying to stop the flow of the current. Even though it is a conductor, it tries to stop the flow of the current. We can take an example of a friction. So friction is a force that acts against a force which is applied on an object. So depending on the type of the object and depending on the type of the surface on which the object is lying, the frictional force may be great or maybe less. So similarly, resistance, it depends on the material. So copper conducts more than tungsten, aluminum conducts more than iron. So there are some differences in the flow of the current based on the material which is being used. So that property that tries to stop the flow of the current is known as resistance, and its SI unit is ohm. The representation is also given. So here there's some talking points. Conductor, so copper, iron, aluminum, these are good conductors of electricity. Then what would be the opposite term of a conductor? Insulator. So we can take an example of insulator, plastic, wood, etc. So insulators don't allow current to pass through them. In other words, the resistance or the resistivity of insulators are infinite. Insulators don't allow current to pass through them. Friction, so there's a term which I've just mentioned. So next we have Ohm's law. So let's start with the statement. At constant temperature, the current flowing through a conductor is directly proportional to the potential difference across each ends. Earlier we have already learned about resistance. So directly or indirectly, Ohm's law is related with resistance. So here the statement clearly says that the current I is directly proportional to the potential difference V. So a simple circuit diagram on the right hand side of the screen. V is the potential difference. A or the voltmeter which measure the potential difference. A is a meter which reads the current flowing through the circuit. So V directly proportional to I, then V equal to IR, where R is a constant called resistance. So R equal to V by I. So that's the resistance. So V by I. So if you plot the graph of the potential difference and current, it will pass through the origin and it will be a straight line. So that shows that as you increase the potential difference, the current also increases. So 1 ohm equal to 1V by 1A. So if the potential difference across the ends of conductor is 1 volt and the current through it is 1 ampere, then its resistance is 1 ohm. So that's a very simple definition. Now let us discuss the factors on which resistance of a conductor depend. So the first factor on which resistance of a conductor depends is length of the conductor. Resistance of a conductor is directly proportional to the length of the conductor. So we have already, I have already mentioned that resistance of a conductor differs from material to material. The conductivity of copper and aluminum are not same. So now there are certain factors, even for the same material, the resistance differs. So the first one is length of the conductor. So R directly proportional to L. So that means if the length is increased, the resistance also increase. Take an example, a 1 meter copper wire and a 10 meter copper wire. So which of these two will have more resistance? So the 10 meter copper wire will have more resistance. Then the second factor is area of cross section. So resistance of a conductor is inversely proportional to its area of cross section. Why do we have thick wires, main wires? Why do we want to have a very thick main wires? So if the cross section area increases, the resistance decreases. So sometimes resistance is very important. Sometimes we need to avoid the resistance, or we need to decrease the amount of the resistance of a conductor. So for a long distance transmission, we prefer a very big or thick wire so that the cross-section area increases and the resistance of the conductor decreases. So as you increase the cross-section area, the resistance decreases. There will be we're going to do some word problems related to this as well towards the end of the lesson, so that will help you understand better. So types of material. So types of material, what type of conductor do you use? That's another factor. Then temperature, of course, is also responsible for the flow of the current. In other words, it decides the resistance of a conductor. So there's a diagram coming up which will help you understand better. Then the last diagram or point, factors affecting resistance. So go through the video over and over until and unless you understand. So let's derive electrical resistivity. We have already spoken about resistance, and we know it's a property of a material that opposes the flow of current. Now what is this electrical resistivity? So let's start using equation 1 and 2 from the previous section. So for equation 1 and 2, we have R directly proportional to L by A. Then R equal to rho L by A. So this rho is a constant called electrical resistivity. Electrical resistivity and resistance are not the same. So rho equal to, on cross multiplication, RA by L. So SI unit equal to ohm meter. Electrical resistivity or specific resistance is defined as the resistance of a conductor whose length is 1 meter and area of cross section is 1 meter square. So that's the definition of electrical resistivity. Now the resistance of the same material, copper, depending on the length and depending on the cross section area, the resistance might not be same, but the specific resistance of copper will always remain the same. So for the same material, the electrical resistivity remains the same. The electrical resistivity of a plastic is infinite, or it's very big that it does not allow the current to flow. So electrical resistivity is defined or is found out by the length 1 meter. We should be considering only 1 meter, and the cross-section area we should be considering only 1 meter square. So that is the reason why it is called specific resistance. So the SI unit is given as ohm meter. So some terms and facts to learn, which I have not discussed. So ammeter, voltmeter, rheostat. So ammeter is an instrument used for measuring current. Voltmeter is an instrument again used for measuring potential difference. And remember, ammeter is always connected in series in a circuit, and its ideal resistance should be 0, whereas voltmeter is maintained at high potential difference. Sorry, it's connected in parallel and its resistance is high. The rheostat is another instrument to keep the to get a variable resistance. Then conductor, insulator, non-ohmic substance. What are these non-ohmic substance? Those substance on which Ohm's law cannot be applied to are called non-ohmic substance. Example, a vacuum tube and semiconductors. These are examples where we cannot apply Ohm's law. Then you please learn about the electrical symbols, the table which is given in the textbook, and the schematic diagram of random motion of electrons, schematic diagram of motion of electrons under applied potential difference. And another very important definition, electric circuit. So the closed continuous path in which electric current flow is known as electric circuit. So these are some of the terms and facts which you need to learn based on what we have discussed. And in the next class, we are going to derive some formula, 1 or 2, and then we're going to talk about combination of resistances. Thank you.